So we start with this international online workshop. Good afternoon, distinguished speakers, highly experienced academicians, and dear students. On behalf of Honorable Founder President, Dr. Ashok Chauhan, Honorable Chancellor Sir, Dr. Asim Chauhan, Honorable Vice Chancellor, Professor Dr. P.B. Sharma, and Honorable Pro VC, Professor Dr. Vikas Madhukar. I extend a warm welcome to all of you. I also welcome Dr. Michael Gaix, Associate Dean, Recruitment and International, Faculty of Science and Engineering at University of Wolverhampton, UK. We are indeed grateful to him for his great support to MIT University and for helping us out with the services of our distinguished speaker, Dr. Mohammad Patwari. I extend a hearty welcome to Dr. Mohammad Patwari, Director, Digital Innovation and Solution Center, and Professor of Telecommunication at Faculty of Science and Engineering, University of Wolverhampton, UK. He is the research head for 5G Connected Forest Project, Wireless Communication System Design or Optimization, and Future Generation Cellular Networks. He is Charter Engineer of the Engineering Council, a senior member of IEEE, and co-chair of Testbed Working of International Network Generation at IEEE. I also extend a hearty welcome to Mr. Benjamin Lionel, consultant and ex-director of Instrument Research Development Establishment, that is IRD, Dehradun, and ex-director of International Cooperation at DRDO headquarters. He settled in London and he joined us from there. He has over 36 years of experience and has been awarded with Path-Breaking Research Award and DRDO Award for Professional Excellence. I also extend welcome to our Honorable Professor Dr. Vikas Madhukar, our Pro Vice Chancellor and Dean Faculty of Management, who has over 20 years of experience in this academic world. I welcome all the participants to this great opportunity wherein we will have deliberations on trends in communication systems and electro-optics. Wish happy learning to all the participants. Now, I will request Dr. Sweta Tripathi, our expert in the field of communication, to proceed with the proceedings. Thank you.
Thank you, sir. Very good afternoon to all honorable dignitaries, esteemed HOIs, faculty members, and dear students. Trends makes the world go round. What we are looking for the society is constantly changing and evolving. And communication world is not immune to revolving trends. We have seen overwhelming and sometimes exhausting number of changes in the field of communication systems and sensors. With the vision of globe-spanning ubiquitous optical network, a sustainable and reliable communication infrastructure for users and devices around the world, electro-optic communication field has an important role for defense sector to the space programs, to the basic needs of human beings, including the internet to the internet as well. So today we are gathered here with one of the most important topic of the discussion, trends in communication and electro-optics. So I, Dr. Shweta Tripathi, extend you a very warm welcome. We are extremely privileged to have among us our honorable guest speakers, Professor Dr. Mohammad Patwari from the School of Engineering and Computing and Mathematical Sciences, University of Wolverhampton, UK, and Mr. Benjamin, consultant and ex-director, Instrument and Research Development Establishment, IRDE, Dehradun. We are enormously privileged to have among us Honorable Pro Vice Chancellor Sir, Professor Dr. Vikas Madhukar, Director AIDT, Deputy Director Major General Dr. J.S. Tull, Head of the departments and other senior members of the academic fraternity of Amity University, Haryana. It's indeed a pleasure to have you all with us today. So let's start with the proceedings. So, Professor Dr. Vikas Madhukar, Pro Vice Chancellor of Amity University, Haryana, specializes in finance and strategy and holds his doctorate in international finance from Kurukshetra University. Dr. Madhukar is integral part of Amity University, Haryana from its inception. He has rich and varied experience for more than 22 years in teaching, training, research, consultancy, and administration. A guide and a mentor, he leads with collaborative approach and possesses excellent multitasking skills. May I now have the honor to invite Professor Dr. Vikas Madhukar, Pro Vice Chancellor, Amity University, Haryana, to kindly enlighten us with your words of wisdom. Sir, please.
Thank you, Dr. Shweta. Thank you so much. On behalf of our Honorable Founder President, Dr. Ashok K. Chauhan, on behalf of our Honorable Chancellor, Dr. Asim Chauhan, on my personal behalf, on behalf of the entire Amity fraternity, I extend a very warm welcome to our esteemed speaker of the day, Dr. Mohammad Patwari, who is from School of Engineering, Computing and Mathematical Science, University of Wolverhampton, United Kingdom. Sir, we are very honored to welcome you to Amity University, Gurgaon, at this very important session on trends in communication and electro-optics. I also extend a warm welcome to Mr. Benjamin, who is Consultant and Ex-Director, Instruments, Research and Development Establishment, Dehradun. Major General J.S. Dhul, who is Deputy Director of Amity School of Engineering and Technology and also the Director of Amity Institute of Defense Technology at Amity University, Gurgaon. The head of the institution, those they are attending this program, and all participants. Amity University, Haryana is a multidisciplinary university. We are offering more than 108 programs in the various disciplines of management, science, engineering, psychology, liberal art, planning, law, architecture, medical and allied health sciences. At Amity, we are truly committed to the cause of innovation and committed to contribute in the progress of humanity through excellence in education, industry and society relevant research, and adopting sustainable management practices. I'm proud to share that our university campus has been ranked at 32 by Times Higher Education Impact ranking. The 32 rank we have received in energy conservation. We have also been ranked at 63 in the world in water conservation. This is the first university campus of India and second of Asia to get US GVC LEED Platinum certification. Our university has been accredited by NAC Grade A University, which is a testimony of the quality of education which we are imparting to our student. The today's topic on trends in communication and optoelectronic, I feel, is of great importance and significance for everyone, especially the optoelectronics, which has become increasingly important in a wide range of automotive, telecom, industrial, and defense application. The high beam quality and low energy consumption optoelectronic for superior performance at a very low cost. We have seen that how the optoelectronics has changed the future of communication and particular the telecom industry in India. I remember the days when the telecom industry was in its nascent stage, and how the reliance with the adoption of optical fiber technology has introduced the Reliance Infocom, and which has not only incorporated the efficiency in telecom industry, but also brought down the tariff substantially. And now, especially when we see the advent of many new technology like Internet of Things, big data, cloud computing, virtual reality, artificial intelligence, we feel that there is increasing need in society for high capacity data transmission, raising the bar for optical fiber communication technology. And I feel that the way our scientists are working, the way they have achieved a breakthrough, allowing us to go from one place to another place in a matter of seconds. So truly speaking, the optoelectronics, I believe, is very significant for industry, and it is very important that the technology should be used judiciously so as to reap the maximum benefit and improving the efficiency in industry and various fields. I'm sure that today's workshop, Trends in Communication and Electro-optics, is going to throw an important light on this significant topic. I can see Dr. Mohammed is going to speak on trends in digital and satellite communication, and specifically where he is going to address on development of 6G wireless system. Dr. Benjamin is going to speak on electro-optics trend in defense system. The discussion is going to be truly focused on defense sector, followed by Major General Dhul, who is going to speak on defense sector opportunities, particularly in the related area of communication and optoelectronics. I'm sure that the seminar, the workshop is going to give a useful insight to the participant about the topic. And I wish all the best to the participant. Thank you.
Thank you so much, sir. Professor Dr. Vikas Madhukar. Mohammad Patwari is a director of Digital Innovation and Solution Center, DISC, and professor of telecommunication at Faculty of Science and Engineering in University of Wolverhampton since June 2020. He is also the research lead for 5G Connected Forest project funded by Department of Digital, Culture, Media and Sport, DCMS, that aims at accelerating visitor economy in Midlands, and director of European Regional Development Fund, ERDF, supported by Project Digital Enterprise. He was a full professor of telecommunication network and digital productivity and the head of Intelligent Systems and Networks ISN Research Group at School of Computing and Digital Technology, Birmingham City, University, UK between 2016 till 2020. He was also the principal data architect for large-scale 5G testbed in UK to accelerate digital productivity and to develop urban connected community with West Midland 5G during 2018 to 2020. He was also full professor of wireless system and digital productivity and the chair of Center of Excellence on Digital Productivity with Connected Services, Staffordshire University until 2017. And his current research interests include sensing and processing for intelligent systems, wireless communication system design and optimization, signal processing, and energy efficient systems. So may I now request you, sir, to please give the expert lecture on the topic, Trends in Digital and Satellite Communication, Development of 6G Wireless System. Sir, please.
Thank you, Dr. Shada Tripathi. Can you see my screen? Can you hear me
yes,
okay?
Yes, sir, it is perfectly visible. Yes.
Okay. Sure. Okay, so firstly, thank you for inviting me into this. And especially I like talking to younger minds, next generation researcher. This is what we can leave behind us as legacy. So when you've been looking at the potential audience into this particular workshop, as you said, I tried to put together a number of things, the expertise that I had when I was working as a co-chair for Future Network Initiative from IEEE. I'm looking at the testbed working groups. Also in ITU, they try to look into how can we facilitate experimentation to wider community. So we are offering federated testbed for next generation wireless communication development. And also we are aiming at connecting many people around the world. I'll be talking about that a little bit later, and in that regard, I'm also looking into a competition called Connecting the Unconnected. So putting everything together, having the audience in mind, I'll try to share my idea that last 6 years when I was working into 6G wireless systems. So as we go, I think I have 45 minutes. I will try my best to put things together. First, I try to give a background, what exactly we'll be taking forward. And then discussing in everything in the perspective evolution of wireless communication, then identifying number or a set of paradigms so that they, as I said, younger generation, they can take the research forward. And specifically, I'll be looking at what does 6G aim to deliver? And then if we're aiming at that, what kind of benefits they can bring to our society? And of course, finally, summarizing what exactly we're going to achieve. So this is a typical cellular system. So every time we talk about wireless systems, typical scenario come into our mind. Moving away from traditional landline, when you want to provide mobility, we segment a geographical region into small cells. We call them that geographical segment, we call them cell. And then we try to send signal wirelessly and making sure we have infrastructure to connect wherever we are in the world. Now, one thing for the audience, as I said, I'm looking forward to some younger or next generation researcher. The only thing wireless is between the user and this base station as we speak. The rest of the others, they have very strong optical infrastructure or wired network in it. So the second half of the lecture, you'll see one of our speakers will be talking about. I'll be looking into wireless between that user and that service base station, if you like. I was hesitating to say base station because I tried to use a metaphor here for younger minds that imagine I want to illuminate an environment, a geographical region. I will have two options. Either I have a big candle, then it can illuminate wider area, or I can split that candle into multiple components and then decentralize them. When it comes to wireless communication, you can see this base station doing exactly the same thing. Instead of having one transmitter that can cover bigger geographical region, we split them into small segments. Then eventually, they're serving the users to connect with that, as I said, wired optical network, if you like. So in a typical cellular system, you can see user talking to the base station, then eventually that goes to significantly strong component of the network, mobile switching center, then that become part of our central network. This is how it's been served. So this is one item I want to share. The second thing, as I said, this is the foundation when it comes to communication. Widely known, I'm sure all of you have studied that in your university degree, Shannon's theorem. We do have, in communication, we have a transmitter, we do have receiver, and we call channel. Now, this is the thing, when I go to the class, I tell younger students that channel is the most important element you need to understand. It doesn't matter which generation of communication you go to, everything is about the channel. So let's imagine the channel is a pipe. If you want to establish a network to transfer some water, you need to measure how much water demand you have. On that basis, you are going to fix, this should be the kind of size of pipe I need to employ here. And then how much water you have, how much water you can generate. At the same time, how much water or how much resistance you're going to get whenever you are making that water to flow. So putting everything together, you can see in communication what will be the capacity of the channel. That will depend on to the bandwidth. If I say the width of the pipe, the diameter of the pipe, as you say, and then as I say, friction that water going to face, it could be anything, it could be dust or anything. So in communication, we call them noise, and of course, power that you can transmit. You're not allowed to transmit infinite amount of power because, as I said, the distributed environment, it will interfere with neighboring candle or neighboring base station. So whichever kind of communication you're talking about, this is the foundation. Always you need to think, we need to come back to the capacity, bandwidth, the power that you're transmitting, and the noise you have to deal with. So taking everything forward, we do have evolution of wireless communication, starting with first G, second G, 1G, 2G, 3G, 4G, and of course 5G is running. We had all the innovation was driven by some technological problem. For example, in the first G, we had analog device to deal with analog process. Then we move into digital in 2G. In 3G, we try to provide some data. In 4G, we try to make this data flow to be faster. As I said, the water flow to be faster. And then in 5G, things have changed. In terms of innovation, things are changing significantly. I'll tell you what it is. When it comes to 5G, we try to connect things together, more devices connected together. Why it is different? Because yes, technologically, we can connect a lot of things together, but how we're going to use them? So this is the kind of thing we'll try to discuss a little bit later. So we have two different kind of evolution. First, you can see the mobile phone has changed. Of course, the technology has changed too. But from 5G onward, is actually innovation is driven by user demand. How people want to have access to data. Number one, why they want to have access to the data that fast, for example, or what benefit is going to bring. So 5G onward, always we need to keep in our mind that how we're going to use them. So if I take you back to the metaphor said, you have a bigger water pipe, that's okay, but how you're going to use this water? Do you really have this amount of demand? So if you do not have demand, we may need to think differently. I'm going to share this slide to you, but I'm not going to read out all of this. The number of favorite element that I want to take you to into 5G, that is data latency. So in 5G, we think of having 1 gigabit per second data. If you compare 1G, 2G, 3G, and 4G, they are significantly low. And the other thing, you can look into the latency that we have, 1 millisecond. In theory, that's what we are offering from 5G. What does this mean from a user perspective? If you compare this with human behavior, for example, human eye can detect there was an interruption if it's 1/10 of a second or 100 milliseconds. So that's human eye. So why 1 millisecond is useful? Whenever machine want to perform something. I'll try to relate that number a little bit later too. And the other thing you can see at this point, the service type. This will be the defining factor as we move into 5G or beyond. So what we are doing, dynamic information access, we have wearable devices with AI capabilities. And of course, rest of the other generations, most of the audience hoping we're familiar with, but you do not have much practical set of information into 5G. Let's focus on that. So all of this evolving towards, I would say, 3-4 different paradigms. I'm going to talk about 3 of them here, as all of you are aware of. When I teach that in the class, every time I talk to a student that all of you hear Internet of Things, what does this mean? What is things? Okay, so we try to give life to some object. What, as we say, things, they cannot sense. It means sensor come to the play to sense physical parameters. So when you have those kind of non-living objects, we feel there's some uncertainties around it, or they can cause some uncertainty. We try to create a network by giving some electronic sensors. So Internet of Things, in other sense, we can say it is a sensor network, but in the perspective or the paradigm, we call them Internet of Things. So when younger researcher, if you want to walk into this particular paradigm, there are a number of ways you can do research. For example, how do you think this kind of non-living object, they should form network? What kind of sensing capability should be useful? We should consider to give them life. What kind of data that you are going to get? How do you ensure data fidelity or data quality, for example? Since they are low power device, how can you provide security? So all of these elements is come to the scene into this. So please do consider if you are researching into this particular paradigm. The second thing you look into cloud computing. One of the things, as I said, when I'm talking in the class, cloud refers to particular metaphor that we do need computing power. We don't worry about the location of that computation power. So computation could be either running a simulation virtually with high-performing computer or storing your data. So there are 2 different aspects you can see where location is not relevant. Why location is important? For example, you really want to have something done and you want to see that real time. That's maybe difficult. So when you look into cloud computing, make sure what application that you have. If you want to do research again, we need to find out with respect to certain application, how easily we can get access to those computing facilities. How can you make them available to particular applications as you're walking into? How do you ensure they're secure? And this access, can we provide autonomously? So depending on your application, of course. Now, this is the thing quite a lot of the students, as I say, younger mind, they talk about that edge computing. Here's the problem. As you say, cloud computing, we don't worry about location, but we may ask for nearly non-real time or any kind of non-real-time activity. I can store data, I can simulate data, then bring some results, but of course, as I said, non-real time. But if we really want to outsource those kind of computing facilities, for example, taking internet on board, these devices, they will have low battery. I mean, battery power is not be significant. At that point, when you do communicate, if you're letting those devices to communicate wirelessly, we have 2 options. Either transferring this data significant distance, or do this computation somewhere not with them locally. So whenever this kind of computation facility is coming closer to those devices, we define that closeness to the edge. So we are providing similar kind of computing facilities, but taking it closer to the device, but not necessarily inside the device. That relates to edge computing. So unlike cloud computing, one additional element you do consider that energy efficiency of the network, because the devices that we have, they do not have significant energy resource with them. So putting these three together, and whatever communication facilities 5G can provide, this is how we're evolving towards 5G and of course beyond. So if I just spend some time into what exactly 5G is giving to us or offering to us at the moment. First, it can give us enhanced mobile broadband, where we need significantly high volume of data. So if I had used that physical metaphor, remember I said water pipe, you're giving us bigger water pipes so that the amount of water you want to consume, you don't have any problem, but faster. A second thing, it gives us a massive machine type communication. As I said previously, that Internet of Things, in theory, it says 1 million devices per square kilometer. It sounds quite a big number. But if you go a little bit down, 1 million devices per square kilometer means one device per square meter. Imagine a classroom of 30 square meter, and you're putting 30 students in the class. Each of them has most probably one or more than one device. So that already saturates that density. Remember, we are not talking about 1 million devices in the whole country, whole geographical region. In particular environment, if you really want to have 5G access point, they can provide connectivity where one device per square meter, that kind of density. The other thing, you can give wider data, that's okay, many devices, but ultra reliable and low latency. And this is where things come to the play. When you say latency to be 1 millisecond, what does this mean? As I said, human eye can recognize 100 milliseconds or higher, not lower than that. But machine, for example, you use wireless connectivity into an industry where you have a machine is rotating, for example, 3000 RPM. Imagine those measurements. If that has to synchronize with the neighboring machine and the communication between wireless, and if it is less than 1 millisecond, if you miss one thread out of the 300 RPM rotation, then your production will be defective. So this is how we can relate this latency to machine. There's a number of applications. As I said, I'm not going to read into this, but this slide will be available to you. You can take a look into that. But as a summary into this, where do you need 5G or maybe future network? For example, we do have some repetitive job where we want to share information together. There's some wireless element into it. For example, a human is taking a camera and then act as a surveillance operation around monitoring a building. For example, I'm talking about the health of the building or health of the equipment, a power plant, for example. Every week, a person goes around and see, or any period of time, they're looking into that. That person can do mistake because the path he or she is going to follow will not be exactly the same as a machine can do. So those are the kind of precision activity which is repetitive and it needs quite a lot of wireless data. That's where we are going to use 5G. 5G is not for voice. 5G is not for just data. When you talk about latency, reliability, ultra reliability, ultra low latency, so these are the kind of machine kind of applications we are talking about. So as you can see, you're talking about industry. Right, so this is what we have. Now, what is next? If you take a look at those in 6G, as I've been looking into 1G, we do have certain features. Let's start with 5G. In 5G, we're looking at machine to provide services to human, but they can talk to each other. Ultra low latency is absolutely fine. As the number of devices growing, we really need to think about how to tackle energy and where those energy be coming. So 6G and future networks, we are really concerned about a number of things. Number one, how can we connect people more, but energy efficient way? At the same time, since we are depending on machines so much, make sure we are not letting our people down. We are not letting machine to do everything for us. We expect humans should stay. So on that vision, we do have two agendas as you move on, but let's look at a number of interesting features. What you have in 5G, as I said, you have data rate and latency. So my favorite one is latency, as you said, that 1 millisecond. But for 6G, we are aiming up to 10 microsecond. So how it is possible physically? You'll see there are some applications I'll be talking about. Just one example I want to take forward, that if you have a CPU and a monitor, and if you connect it with where? HDMI or any data cable, the latency between the CPU and the monitor is around 30 microseconds for this kind of wired data transfer, okay, not wireless. And then if we can go up to 10 microseconds, that will change quite a lot of things. The device type that you're looking into at the moment in 5G, we can think of certain machine like smartphones, sensors, and drone. But if we go into 6G, one of the things we are focusing on to holographic teleportation. We do not have enough computation power, local computation power, to make it in public for the time being. But on the lab, we do have holographic teleportation. And this is other thing we are looking into, that consumer electronics supposed to change. Another element we are looking into in 5G, that localization precision is 10 centimeter, and this is 2D, but we're looking at actually up to millimeter in 3D. So, okay, so these are the kind of features that we'll be looking into. So if we move forward into this, just to realize how we are evolving and why, in 1G we had voice, in 2G we had text and voice, in 3G we had multimedia and voice to data, as I said. 4G gave us fast mobile internet, and 5G we wanted to connect things together so that machine can do a lot of things for us. Please do remember this. We are heavily getting dependent onto machine. We collect data, put everything together, that's it, machine is doing. And then 6G will rethink about it. Okay, are we giving everything to machine? Is it good for society or not? So tactile internet or tactical internet and internet of skill and new ecosystem for consumer electronics will drive the next generation. As you can see, you're talking about industry 4.0 and 5.0. So let's talk about one of them, as you said, consumer electronics. I call it consumer electronics 2.0. 6G will drive it. So if you look at why ITU and of course IEEE, they are focusing into this, we need to think how can we connect everyone? Because at the moment, technologically, so many things are possible, but still, as UNESCO said, quite a lot of people, they didn't even see, or half of the population in the world, they didn't see broadband. Or ITU said 2.9 billion people still offline, which is 37% of the world population. So if you think about connecting many people together, whichever way it is possible, devices will need energy. Then industry, they say that there'll be significantly increased energy demand, you can see. So the way we rethink that consumer electronics is, just take a look at that. In conventional wireless, we said a user will be connecting to the base station and the rest of the others would be sorted, right? And why most of the people, they are unconnected for the time being? Device cost is significantly high. That it's not affordable to those people that we are referring to, at least those 2.9 billion people. Why? Because if we think this device as that normal computer that we have user interface, and also we have a processor. Now, processor is the most expensive element that makes the device cost to be higher. And if you remember, I said that we're looking at the latency of 10 microseconds between one source to another. If that is possible, then taking the example of monitor and CPU communication, if that is type 30 microsecond with wire, and if we can provide 10 microsecond delay with wireless communication, most probably we don't need to keep this processor in a dedicated phone. We can borrow computation. So future wireless communication can facilitate on-demand edge processing. Remember those edge computing I was referring to? It's something, some computation power closer to the device, or as in this case, user interface. And then we do have those kind of devices, like your mobile phone, your smartwatch talking to your mobile phone. So we're not talking about something new. What you can see that wireless mouse we have, wireless keyboard we have, but we do not have CPU and monitor that's wireless. This is because the latency requirement between them is 30 microseconds or lower. Now, if you go to that 10 microsecond possible latency in wireless communication, this is possible, which means this CPU can stay away, right? Then if this is what we try to do, which means we need to find a space to facilitate this kind of computation. And if you have computation demand, you need energy. So another company I'm working with, you can see the dimension of this server. It is a credit card size kind of processor. The depth is a little bit more, but in terms of length and width, you'll see. So it is i7 processor, which takes 10 to 25 watts of energy. If you have Intel i7, that takes 200 watts. So yes, we do have some kind of evolution towards this. We can use this kind of computation. As a result, what you're getting, we can connect many people, because the people who couldn't afford those kind of smart devices, we can reduce the device cost, because processor, you don't need to buy a processor. All you need to do, just the user interface, which will be affordable. At the same time, you don't need to, you'll not be spending much energy either. User interface, for example, your current phone, you're taking any kind of application, for example, for text, you're turning on your smartphone. If you want to download a video, you are again turning on the same computation. So that could be optimization into energy consumption too. And then this is another area that will drive future network. As I said, we are eliminating human from the equation. All of you are aware of 4G, but if you take a closer look in the problem that you're creating, in 4G, yes, we do have IoT devices. We are connecting them. Yes, they have data dependency, but we don't care what kind of impact it will have into people and society. All we want to prove this technology is working. So any success is technology deterministic. And then if we go to AI development, we do have quite a lot of flaws, and there's no way we can correct them. So that's correlation-based AI. And then what it does, it minimizes per unit cost of productivity. So literally, if you are a business owner, you like the technology because your productivity per unit cost is low. You don't care about the people. People are losing their job. So it's primarily, it is profit driven. So that creates social division. Now it's time to look as a society or lawmaker, we need to think about it. Are we moving the right direction? For many different reasons. Look, we do have IoT, we do have connectivity and data, but we really need to think human in the equation. How much impact human going to have? So technology should be human-centric development rather than just technology make it a success. If you have an AI, not necessarily AI will do everything right. There should be an option to verify that with human. Of course, there should be latency element come to the play. And then if we do, yes, we do have productivity that should be competitive, but main ambition should be worker empowerment, generating competitiveness, and of course, environmentally sustainable. So when you're working towards Industry 5.0, we're actually looking to social and environmental inclusiveness into this, but most importantly, we are making sure any kind of technological development, you think about the whole thing. You need to have responsible innovation. If I give an example, at the moment, globally, because of the climate change, we think of how can you eliminate coal from electricity generation? Although coal can generate electricity, since it is harmful for environment, we try to avoid it. Technology development should be regulated exactly the same way, that how harmful that would be for human and in society. Not necessarily that technology is working, how harmful it would be for environment. For example, if you do run an AI in the first computers, first computing facilities, how much CO2 you're generating? So that should be a benchmark that will regulate those kind of technological development, which is supposed to be human-centric. So if I go, why you call them Industry 5.0, that will give two different elements in the equations. One would be Internet of Skill, and of course, this kind of new generation of consumer electronics to ensure human-machine coexistence in real-time parallel skill sharing. So humans should not lose job, but yes, productivity should grow. Just quick example I want to see for when you say Internet of Skills, by definition, it will allow us, of course, as human, to teach, be taught, and execute action remotely. So when you talk about this action, remember with this as 6G, that should be latency would be significantly important element to apply all of this. What would be the challenges? When we think let machine and human to coexist, we need to understand what machine can do, what human can do, and of course cannot do. And when you say can do or cannot do, who are efficient into a particular aspect? And a machine was doing something and a person was doing something into particular objectives. if the objective is changing, same person, same machine may need to rethink their task. So we need to have goal-oriented task optimization. When whichever way understand look into identity learning, what means that machine learns something, some task, given aspect. In different tasks, learning. This is another of research or what. As we are promoting human, sure, human can cope or machine can cope up with human empathy. Also, for particular element, we need to understand what kind of computation demand we have. We need to recognize that and allocate same amount of computation. Then what kind of machine we should allocate, how much it can learn, because it needs quite a lot of memories, for example. As you said, edge processing as a service will come as a new business model, and cybersecurity will come to the play. If any of you want to do research towards your PhD, for example, for future networks, we always need to rethink that. We need to find a question how machine and human can coexist. And if they want to learn together, what would be their speed and accuracy requirements? How can they learn autonomously? And of course, find out open source machine interface software. Is it available? Can we make them available? Right, so if you look at, if you would have 6G now, for example, what it will enable to us. So 6G will give us, as you said, terabits per second data with 10 microsecond delay. And then since it is high-speed data, we can have on-demand computing processing, for example, computing as a service. That's a new business model coming in. If you can use that as an example, 20 years ago, if you go to a restaurant, you need to pay for Wi-Fi connection, which you don't need to do. So we are evolving towards computing as a power. So there will be a bank of computation you can go and borrow when you take your user interface. And since those computation devices are smaller, it should be more energy efficient. Since they're smaller, cooling requirement would be smaller as well. So eventually it will take 40% less amount of power. Since we can borrow computation, we will have next generation user equipment come to the play. It will be cheap, so we can accommodate many users. So as I said, 2.9 billion people who doesn't have access to internet yet. We can connect many people. The weight would be light, and it would be environmentally friendly, because the amount of mobile phone that you have, e-waste is a big problem. So that can address this. And most importantly, look at the society. We can have real-time telepresence or telefunctionality by Internet of Skills, which means we can rethink of regulated industry revolution where humans should be integral part of it, as I say, Industry 5.0. So if you look at the trend that we're building up for future network, we are moving towards greener communication ecosystem. Computation-wise, as I said, you can see monitor and computing or computing processing as a business. Greener computing technologies coming in, greener data ecosystem will be building up, because energy will be a big challenge for us. And communication business model, as I said, computing can provide it as a service to enable your mobile devices or electronic devices, to consumer electronics, to be functional. And as I said, e-waste is a bigger problem globally. E-waste management policy will be also taken into consideration. So that was it from my side, and I'm happy to answer if you have any question. Thank you. Can you hear me?
Yes, sir, we can hear you.
Okay.
Yeah, anyone has any question, you can put it in the chat box, or you can raise your hand, please. So what is the progress of development of 6G in your area, sir?
So as I said, there'll be a number of things. One of the key elements is latency.
Yes.
And latency, energy consumption, as you speak. So in our lab, we do have a Linux-based, the i7 processor I showed you. We build it up in here. At the moment, we managed to get I think 5 milliseconds, that's what we didn't go to a microsecond as yet, but as a principle and a framework, considering energy, considering latency, we are working into that. So at the moment, latency, we didn't achieve that yet for a number of reasons, and energy consumption is coming, but key element there is actually AI, because number of places, we need to understand which network behaving what and when. For example, if I come to university campus, at that point, students' data requirement is different. So if you look at the data flow, data demand rather, is different, and network need to reconfigure themselves. If you say for 5G, which base station they need to turn on, and when. So when you look at 6G, all of this should be pre-planned with AI driven. The problem that we have, we do not have that AI as yet. So the worldwide, if you look at Virginia Tech, and of course I'm working with Bristol and Surrey there, we are collecting this data. So at the moment it is quite early stage, but focusing into getting data set to train so that some of the computation they don't need to do online. So if you can take this computation load away, then latency can come down. At the moment, we could not make any progress into this, but in principle, all of us agree. ITU and 3GPP, we are working on that.
That's really great, sir. Very nice. In India also, a lot of work is happening, sir, in this field. And indigenous equipment manufacture is happening for 5G, and people are working for 6G also. So yeah. By, I think, collaboration, I think we should go ahead with this technology at a faster pace. I'm sure that is going to happen.
Yeah, sure. As I said, when I was putting everything together, I was looking at potential PhD student or younger academic who wanted to become a nationally renowned researcher, and I'm happy to help with my team.
Very nice. That's great. Very nice. Any other question from any other participant?
Thank you so much, sir, for such an informative lecture. It was great to hear you about the evolution of 6G and how these wireless communication systems are different from each other and the new prospects which you told us. Thank you so much, sir, once again. So our next guest speaker is Benjamin Lannon. So I'll be introducing him. His professional qualifications include MTech Optical Instrumentation, IIT Delhi in 1985, MSc Physics from Madurai University in 1983. So talking about his field of specialization, he has the specialization in design and development of indigenous EO systems, system engineering of electro-optic instrumentation for military vehicles. He has the expertise in proving of weapon system performance of armed fighting vehicles. He has completed 36 years of service in DRDO in various capacities, namely, he was the Professor Optics and Photonics Center in IIT Delhi, International Corporation Director in DRDO Headquarters, New Delhi, IDRE Dehradun, DCV HPO Second in DRDO Headquarters, New Delhi, Associate Director, CVDRE Chennai, Technical Advisor Defense in HCI in London, Team Leader Fire Control System, Optical Designer in CBRDE Chennai, IRDE Dehradun. He is presently working as a freelance consultant based in London. He has a very rich experience in networking and arranging projects with various government agencies, formulation of collaboration with foreign institutions, design and development of indigenous EO systems, corporate support and MOD interface for DRDO, induction of 124 MBT Arjun into regiments, nodal interface and support of DRDO activities in Europe, integration, evaluation, and proving of weapon system of Arjun. He has conducted 12 stochastic publications. So talking about its award, research awards, he has got the Outstanding Technology Development in 2019, Technology Group Award in 2002, DRDO Award for Performance Excellence in 1996. So may I now request you, sir, to kindly give an expert lecture on the topic Electro-optics, Trends in Defense, Trend in Defense System. So kindly, sir, please start. Thank you so much.
Am I audible?
Yes, sir, you are audible and your screen is also visible.
Okay. Good afternoon, everybody. And I would like to thank Amity University and especially General Dul for inviting me for this. And I would like to record my thanks to Dr. Patwari for the enlightening lecture what I was listening to till now. And I would like to focus on the relevance, on the significance of electro-optic systems in defense to the audience. And first of all, the modern battlefield is a complex ensemble of various technically intensive systems from the land, sea, air, and space. And as we are all aware, this threat is ever evolving with the technological growth which is happening all over the world. Now, the electro-optics devices are no exception to this, and a lot of developments are taking place. I would like to just briefly touch upon the major, major things. I will only touch upon because of the paucity of time. Now, as we are all aware, now whenever there is a product or a person in a battle zone, this is a very basic tool, which is to understand the survivability of the person. And this is known as the survivability onion, which many defense personnel and the defense experts are aware. The logic is that when in a combat zone, and when you know that there is a prevalent threat, then one of the keys for survivability is avoid being there. Avoid in the sense that not that you don't enter the theater, avoid being somehow coming into the direct line of threat. And second is, even if you are there in the zone, then avoid being identified. And if you are identified, avoid being acquired. And if you are acquired, at least prevent yourself being engaged. And in case you are engaged also, try to avoid being hit. And this is the basic rule, thumb rule. And the electro-optic systems have a role in every one of these, both from both sides, either in avoiding or in acquiring. So I would like to just briefly touch upon all these things now. Now, when we say electro-optic systems, we are talking about the systems which are working from the ultraviolet region to the visible and to the infrared region. And there are various types of sensors which work in these different regions. And broadly, the electro-optic systems in today's battlefield could be classified into broad 4 categories: surveillance systems, targeting systems, ranging systems, proximity systems, and of course, the optics itself being used as a weapon, which is an upcoming domain. And these systems are platform specific for land, sea, and air applications. And not only that, they are designed to meet specific operational requirements. And one of the guiding factors in these systems is that they have to be compact, rugged, user-friendly, and easily deployable. So some of the major systems which are being used in the various forces, the airborne systems or the optronic sights, which is used for reconnaissance and airborne observation, and the pilot use helmet-mounted displays and night vision devices. And in the land-based systems, it is very intensely used by the infantry soldier, and it is also used in the vehicle-mounted systems and for the surveillance and other land-based applications. In the naval systems also, we have the systems, electro-optic systems, which are being used for firing their main weapon, and the underwater systems also use them. Now, the relevance of electro-optics is to be understood because the focus on, due to the focus on the national security, most of the countries these days, they require night vision devices, electro-optics and IR sensors for patrolling, surveillance, reconnaissance, and search and rescue operations. And R&D in these systems is increasing, and the global market for the electro-optic systems is also very rapidly increasing. As you could see here, the market forecast is 14.2 billion from 11.3 billion, and in the next 2 to 3 years. It's a very important investment which is coming up in this domain. And now coming to the various systems, one is the land systems first. In the land systems, these are the various types of surveillance devices. Now, these are used mainly to peep into the other side, and they have varying ranges. And in this particular case, you can see that this is actually a radar, and this is an electro-optic device which is having a day camera, a thermal camera, and a range finder. And this is another one which is again used for land-based systems, wherein you can see the you can see the incoming threats. This is again another for the surveillance, where you are able to do a surveillance in the air. And but in all these devices, the current trend is to do an image fusion. So here you see a template of 4 sensors: long wave infrared, a medium wave infrared, a short wave infrared, and a day CCD camera. And this is a device which does the image fusion, and it is displayed. So this gives a very good input in the theater of war. Like here, you see here, this is a day camera view, and you see only this part of it. Now, this is the thermal camera, and then you have the image fusion is seen on this side. So this gives a big advantage in an actual theater of war, because what can be hidden in one wavelength cannot be seen from the other wavelength. And but once you have an image fusion and you are able to see over a wide spectrum, then you are better informed about the scenario. Now, other systems which are in use today are the infantry weapon sights. And in the olden days, you may be aware that we used to have the iron sights. But currently, there are 2 major systems. One is the reflex sight, in which there is a dot, which you can see here. And this dot has to be just put on the target, and you can fire. And this is it aids the gunner for a quick reaction, unlike this case where he will have to put the aiming mark and in the center of this, and it involves some sort of a skill, whereas here you have to just put the dot on the center and you have to fire. And another system which is, I wouldn't say that it is the same, but it is similar to this, is a holographic weapon sight, which is in huge demand. And you must be aware that these type of sights The reflex sights and other things are even used in hunters' sights. So in the hunting, people use it. But today, their application has extended for close combat and for a better efficiency, to provide a better efficiency to the soldier. Now, another device is a image intensifier based system, which is the basis for the night vision devices, in which we have a photocathode and then a microchannel plate, which expands the or which amplifies the incoming radiation, and which is displayed onto a phosphor screen and which can be viewed. And these systems are having various generations, and various generations, when we see that it is higher efficiency, longer life, and smaller in size. So various generations have come, and they are very widely used. And these are some of the devices which are in use with our armed forces. These are all image intensifier based devices, and they are used for as weapon sights also, and for the passive night vision binocular, and even for measuring the gaps and other things. And another device is the uncooled thermal sight, and these are microbolometer based systems, and these are the various devices, and their utility has been expanded to the driver's night sight also. The main advantage of these uncooled thermal sights is that the image intensifier sights have the tube, the image intensifier has got a defined shelf life. And whereas in the case of uncooled thermal sights, we can say that it is a very, very long, shelf life. And that gives an advantage for the maintenance of these things. And the other thing is the fire control systems, which are used in the combat vehicles. This is a picture of the Arjun battle tank, which is with the Indian Armed Forces. And as you can see, there are a number of, there are almost about 12 devices, optics or optoelectronic devices in this system. Now, this is the tank main site, and this is the driver's site, and there is a commander's panoramic site right behind this. And there are a number of sites. I'll just touch upon a few of them. Now, but coming to this, actually, I would like to just mention here that the main battle tank Arjun is one of the state-of-the-art equipment in its class, and it is comparable to the other world-class tanks. Now, when you compare the limitations of the World War II tanks, the World War II tanks had a very limited range for the main gun, and they didn't have an accurate means to find the distance of the enemy, and they didn't have an accurate positioning of the gun, and they didn't have the ability to fight through dust, smoke, or fog or rain, and they didn't have a night fighting capability, and nor a capability to fight on the move. Now, this is a typical World War II site. You see the stadia lines, and they know what they do in combat is they will try to fit in the enemy when they see the enemy tank. They'll try to fit into this stadia line. As you can see here, this is somewhere around 22 or something. So as you know, as the size increases, the object is closer. So you can see that as the tank, if the target fits smaller, that means it is at around 3 kilometers, whereas here it is around 1200 or something like that. Now, this is how they were fighting, and it had its own approximations of tens of meters. So you may not be able to hit him in the first round. And once you don't hit him in the first round, then he is going to be aware that you are there, and he is going to aim at you and fire. So these were the limitations which have been overcome by the modern electro-optic systems. Now, when you see the modern systems, this is the gunner's main sight, what you see here, and which has got a day sight, thermal sight, and a laser range finder. And similarly, the commander also has got a day camera, a thermal camera, and a laser rangefinder. The difference is that this sight is rotating 360 degrees, because this can be used for acquiring targets. whereas this is completely aligned to the main gun, and he is using it mainly for engagement of the defined targets. Now, this is another view of this site, and so this is the day window, 3i window, and these are all the various modules which are there. And these sites have a stabilized mirror, which you don't see here. It is right behind this hood. There is a stabilized mirror which is isolating the disturbances coming onto this platform, because when the tank is running on a cross country, you will have a lot of disturbances which are coming, but the stabilized mirror, it isolates these disturbances and it is able to give a stable line of sight. Now, this is the inside view, and this is the operations of the day, and this is the control handle for the gun, and this is the ballistic computer control, and this is the operator's handle for the commander side, and this is the one is the day camera, one is the day sight, and another is the thermal sight, and this is the yoke for controlling the main gun. And now, when I say stabilization, I would like to just say, when you are riding a tank and if you are seeing to a side, when there is no stabilization, it looks like this. And when there is a two-axis stabilization, it is like this. Now, in normal combat vehicles or land-based systems, we go for two-axis stabilization. That is for the pitch and the yaw. So, in the case of three-axis stabilization, we do the roll also. So this is used in land sea-based systems, like a ship or a submarine. Whereas these sort of systems are used in land-based systems. This is used even in the aircraft. Now, what is the result of this when it comes to the platform? I'll just show you a small clip. It doesn't have an audio, but this is the German Leopard tank, and the gun is stabilized, and he has put a beer mug on that. You can just see what happens when the. So this is how the line of sight will also remain stable, in spite of the platform undergoing a huge disturbance. The system it is keeping the gun stable. That means the line of sight is also remaining stable. So this gives the gunner an ease of engagement. And these are all devices which are having the electro-optic sensors and other systems in place for ensuring this. Now, this is another technology I already mentioned, the driver's night sight, and it has got, this is the front window, and this is the view from inside. Either the gunner can view through this, or in case he wants to be hands-free and other things, he can see on the display and he can drive, and this is the microbolometer based system. Now, another system which is coming up in a big way in the modern battle tanks is the situational awareness systems. And this is this thing wherein a lot of electro-optic sensors have been plugged on to a combat vehicle. And because the evolving threat scenario for a combat vehicle is increasing by the day. You have threats from the other vehicles. You have threats from the land-based systems. You have threats from the helicopters and from the air. And you have the mines, and you have the shoulder-held weapons, and a lot of things are there. So the situational awareness for an infantry or for a land-based system is becoming more and more today, and the electro-optic systems play a big role in this. And this is one way of classifying a person's awareness and the color-coded awareness of the preparedness to enter combat zone. When he is not aware of the threats which are prevalent in the theater, then he becomes a potential victim. And he is classified as a yellow category if he is aware of that there is a threat, but he doesn't know the threat. And he is classified as an orange if he is able to recognize the specific potential threat. And if he is classified as a red person, that means he is aware of the threats and he is ready to counter them and fight them. And when he is in a black, that means he is fully aware and he is deeply engaged in the engagement. So this is becoming a very major this thing, and in which the electro-optic systems have a major role. In fact, in the current war which is going on in Europe also, these systems have been deployed. Now, this is another this thing just to give you an idea how I just muted it. The current scenario is that when you are in theater, you don't want to be identified or detected, then you fire a smoke grenade. Now, when you fire a smoke grenade, this is how it looks through the day camera. But as I said earlier, you can, today the system is coming with the image fusion and other things. And this is a view through the another TI camera, which is in the 3 to 5 region. So this particular smoke has got a defeating capability to defeat this also. But you can't have smoke which can defeat in the complete broad bandwidth. So what happens is that there are certain bandwidths in which you can still see, like here, this is an 8 to 12 camera where you are still able to see the complete scene without any hindrance. So the problem today is that being stealth or being undetected in a combat zone is a challenge. Now, this is also being addressed through a lot of electro-optic systems and techniques, and I will touch upon that slightly later. Another place where the electro-optics is widely used is the laser guidance. Now, many of the systems are fitted with laser guided bombs. And so what happens is these bombs either have a proximity sensor, or you have to designate the target from a forward post. And if you designate the target or from another tank, then the missile is launched from an aerial platform, and it can be hit using the laser guided ammunition or the bombs. So this is a major this thing which is being used extensively in today's combat, and this is just an example of that. You can see 4,000 meters a laser guided ammunition is. And this is what is left of it. So it is a very cutting edge technology. And now coming to stealth again. Now we are all aware about the how to have a stealth. Now, if you are in the visible region, then you must have a complete sort of a cloak for the visible region. And if you are in the night fighting in the night, this thing, then you must have a signature reduction for the night bandwidth. So a few videos I'll just show you about the technologies which are there. The first one is the what we know, the nature's stealth. So this is what is desirable in today's scenario. So a lot of research is going on in this, but there is one interesting this thing which is reported in open literature. I am just going to show you the video. So as you can see, it is a broadband cloak. And now there is another one which is using exclusively for the thermal region. You can just
Now you see it, now you don't. Well, almost. A new so-called invisibility cloak called Adaptive has been tested, which could one day help military vehicles blend into their surroundings and avoid heat-seeking missiles. So, how does it work? Well, this cloak is basically a sheet of hexagonal pixels that can change temperature very quickly. Onboard cameras can pick up the background scenery, then display that infrared image onto the cloak, allowing even a moving tank to match its surroundings. The maker's BAE systems say a vehicle can also pretend to be something else. For example, here on the left, you can see a tank with adaptive off. Then on the right, you can see it with the technology on, and it's mimicking a car nearby. This, the company says, will reduce the chances of it being attacked. It apparently works both in the day and night, and when the vehicle is moving. When we spoke to the company, they admitted it's not 100% invisible. The outline can be seen by the naked eye. But they told us the main advantage of the technology is that it confuses heat-seeking missiles. They said it could be in production in 2 years' time and could one day be used to cloak battleships at sea.
So stealth is a major requirement in the domain of electro-optics, and a lot of work is going on in various parts of the world, including in India, to have a stealth capability. And naval systems, coming to the naval systems, again, they use the sighting systems, and they are coupled. The sighting system is mounted on a pod, and it is coupled to the gun of the ship, and they do the target acquisition, and then they fire the gun to neutralize the threats. And another major systems which are used in the Navy is the submarine periscopes. This is one typical submarine periscope when they are where they have day cameras, thermal cameras, and then a laser rangefinder, and they have an antenna for transmitting their location and some information, communicating outside, and it is on a mast, and it just comes out, does a surveillance, and then ducks in again. So this is a major electro-optic system, which is a very challenging system of various technologies. And it is few players in the world have developed this world over. And coming to the airborne systems, this is the head-up display, which is being used by the pilots in virtually every fighter aircraft of the modern generation. And now this is the Indian light combat aircraft. And you can see that this is a head-up display. So he will be able to, the pilot doesn't have to look into the panels of all these panels. The essential information is given to him on his display. And so it aids him to fly more efficiently without any hindrance. And now another major system in the Air Force is the airborne systems, is the infrared search and track system. And this is a system which is passive in operation. It gives a wide scan volume of the scene in front, and it can be also allowed to be scanned in a limited range also. And it enables long range detection and tracking of a number of targets simultaneously. So this is a very, important system which is found in every aircraft. If you see any aircraft in the modern aircraft, this thing, you can see a small dome which is jutting outside in the front window, and this is known as the infrared search and track system, and it detects the exhaust plume, the sun glint, the radar, the aircraft nose. These are the various heat profiles, and it is able to detect it from a very, very long distance. And it has got its own technological challenges, and it has got a sensor head, and the information collected is sent through a servo control processor, and there's a lot of image processing done, and it is provided to the pilot. And but moving on, as it has got a lot of challenges, now there are systems which are known as the distributed aperture infrared systems, in which this dome is instead of the dome, they have a variety of sensors mounted all around the body of the aircraft, and so they are able to give a passive tracking of the other flight members, their own friendly forces, and the short range anti-aircraft missiles approach, and it is able to defensive I mean IRST versus the threat fighters it can identify, and it can even see the detection and targeting of the ground system. So it is evolving in this thing, and this gives a full spatial coverage, whereas the IRST used to give a limited frontal coverage. Now, practically all the systems, especially the reconnaissance systems, surveillance systems, the aircrafts or the drones or anything, they have aero payloads for in their this thing, which is belly mounted. Generally, this is a typical this thing of UAV mounted in the belly, and this is an Indian system developed by DRDO. It is fully functional, flight tested, and it can be fitted onto any aircraft. It has got about 8 sensors, and it has got multiple roles, mainly for reconnaissance and surveillance. And the emerging battlefield today, see the main challenge is that the ammunition you have to keep on exhausting, and there has to be replenished. That is number one. And number two is that when you are in combat, now new threats are coming. So when you are the major threat which is coming is the drone, and the drones are coming in so many shapes and sizes. It is very difficult to predict. And expect a particular threat from the other side. So the modern the current requirement is that you develop a laser weapon which can fire a high power laser and neutralize the incoming threats. So this is being developed by many of the countries, and this is one example of the Israeli system. You can just the laser firing of the target. is now engaging a UAV. It burnt it. So another this thing is that as we are all aware, the current battlefield, many robotic systems are entering, the unmanned systems are entering, and this is one such robo which is developed by Boston Dynamics. And if you see this system, it is fully packed with electro-optic sensors. I wouldn't play the complete clip. I'll just show some part of it, then I'll skip. It has got day camera, thermal camera, laser rangefinder, proximity sensors, and image processing systems. So electro-optic systems are entering this. But the major thing, which is another of concern, is this system, which is going to be a system of the future.
We have something much bigger. Your kids probably have one of these, right? Not quite. Hell of a pilot? No. That skill is all AI. It's flying itself. Its processor can react 100 times faster than a human. The stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it does facial recognition. Inside here is 3 grams of shaped explosive. This is how it works. Did you see that? That little bang is enough to penetrate the skull and destroy the contents. That is an airstrike of surgical precision. It's one of a range of products. Trained as a team, they can penetrate buildings, cars, trains, evade people, bullets, pretty much any countermeasure. They cannot be stopped. Now, I said this was big. Why? Because we are thinking big. Watch. A $25 million order now buys this. Enough to kill half a city. The bad half. Nuclear is obsolete. Take out your entire enemy, virtually risk-free. Just characterize him, release the swarm, and rest easy.
can hear it. I can hear it moving. What is so loud?
This short film is more than just speculation. It shows the results of integrating and miniaturizing technologies that we already have. I'm Stuart Russell, a professor of computer science at Berkeley. I've worked in AI for more than 35 years. Its potential to benefit humanity is enormous, even in defense. But allowing machines to choose to kill humans will be devastating to our security and freedom. Thousands of my fellow researchers agree. We have an opportunity to prevent the future you just saw, but the window to act is closing fast.
I'm sorry, Dave. I'm afraid I can't do that.
So that is where the world is heading for. And the electro-optics devices have a role in each and every weapon of use in the theater of war. And as I would like to just quote Albert Einstein, I don't know with what weapons World War III will be fought, but World War IV will be fought with sticks and stones. That shows that the technological evolution, which is happening today, unless it is harnessed and put into the right use, we may be heading for disaster of the humankind. And just to be on the lighter side, in case this happens, what will be the future? I'd just like to give you a small this thing on the lighter side. So thank you for this opportunity, and I would like to take any questions in case you have anything.
Have a question. One of the attendees has asked that since thermal side cannot be also
You are muted.
Oh, thank you, sir. Since thermal sight cannot also detect the object through smoke grenades now, can we incorporate microwaves into sight so as to eliminate that limitation? This is the question one of the attendees has asked.
No, smoke, thermal sights, defeating smoke is a problem if the water content is more. That is this thing, but it is not that they cannot see through smoke. Where the moisture content is more, if humidity is more in the smoke, then the thermal sights cannot detect. Yes, microwave could be an alternate, but that technology will be a more expensive technology. Now, the advantage of the thermal sights is a very well-established technology, and you have it in a broad band. You've got the various band of the thermal region. We have cameras and detectors which are available.
All right, sir. Thank you so much, sir, for such a wonderful lecture. You had given us so many information about the combat vehicles and the fire control systems and the how line of sight stabilization around the 3-axis roll, pitch, and yaw, situational awareness systems, thermal sight at the combat zone. It was very interesting to hear you about the stealth stabilization and stealth capability in the as well as the signature reduction in the night. But the thing at the last, it was very, very, very inspiring, empowering, as well as deadly and dangerous.
Yeah.
Yeah, that small swarm of AI-enabled drones.
Yes.
Yeah, so
that's going to be a deadly development. Yes.
So one more question has.
Sir, I have a question.
Yeah.
Now, the problem that we are finding here in our country is that we are always short of sensors to detect the movement on our borders to do the surveillance of the borders.
Yes.
So we are rushing from one theater to another theater. So are we trying to find some solution of this, some kind of IR device which gives us a larger area coverage, giving us very, very minute details? Where are we in this particular field?
Actually, if you see IRD, I can talk about this thing, and we have developed a system known as the border surveillance systems. We known as called as BOSS, and we have taken the user on board, and we have visited the operational areas, and these systems have been developed, and TOT has been given to the industry also. And this is the very latest development, and I am confident that with these devices deployed, we will be on a I wouldn't say fully this thing, but we'll be on a better level of preparedness, definitely.
Okay, okay. Thank you.
Thank you once again, sir, for such a wonderful lecture on EO electro-optic trends in defense system. So moving forward, Major General Dr. J.S. Tull, VSM retired, Director, Amity Institute of Defense Technology, is an alumni of Military School, Ajmer, and National Defense Academy. He has done specialization in advanced electronics and done Doctor of Philosophy in Management. He has more than 37 years of experience. He has commanded the largest industrial establishment of Army, namely 510 Army Base Workshop, Meerut, and has also steered a very large academic institution of Army based at Secunderabad. His last appointment was Additional Director General, Corps of Electronics and Mechanical Engineers. He has been awarded Vishisht Seva Medal by President of India and has also received Golden Peacock National Training Award from Institute of Directors. Sir, may I now request you to shed light on defense sector opportunities?
Thank you, Dr. Shweta. I'll just share my screen. Are you able to see?
Yes, sir.
Okay.
Yeah.
I'll briefly talk about opportunities in the defense sector because things are happening so fast that most of us are finding it difficult to keep pace with the developments happening in this particular area. Now, the phenomenal growth, why I'm saying is happening in this sector, because we have grown 334% in last 5 years. That is 8 times the exports have grown in India. And as per the latest statement of Prime Minister, we are targeting 3 times defense exports in next 3 years. Mind you, it's the fastest growth rate in the world as on date. In the latest Defense Expo, 451 MOUs were signed, wherein the amount talked of was 1,53 crores. Even in Aero India show of 2023, which happened recently, 809 firms participated and MOUs worth 75,000 crores were signed. It saw participation from almost 98 countries, and there are about 30 defense ministers of other countries in this. We already have trilateral defense cooperation between France, UAE, India, and with other countries also. A lot of things are happening, like US, Israel, and the number of industries getting into this sector is increasing day by day. As on date, as I speak to you, there are 194 startups already in this sector, and more firms are getting permission from the government. As per the statement of Honorable Prime Minister, we are heading to be the drone hub of world by 2030. It's not very far off, just 8 years since. And a lot of tax incentives are being given in this particular sector. For the first time, the government has declared that we will do 75% of our capital procurement for defense services from the domestic defense industries, which amounts to 1 lakh crore in this financial year. And this is going to increase only. And 100% FDI has been allowed for defense through government route, and through automatic route, it is 74%. Earlier, it used to be just 49%. So you see the FDI that is coming in, it's coming in a big way. Our defense exports presently are $1.5 billion, and they are bound to increase to $5 billion by 24-25. Our defense production target is also going up very fast. It's going to be 1.75 lakh crore. And these two dedicated defense corridors out of 5 corridors of industries, they are coming up very fast. And in Tamil Nadu and UP, already 11 locations, the land has been acquired, firms are setting up factories there. And our next target of government is 75% self-reliance in defense weaponry by 2027, just 5 years hence. Maharashtra, on their own, they are also setting up defense hub in 5 cities and adding 1 lakh job. MOD has set up this Srijan portal, which is basically putting the indigenization efforts online so that all can participate. And 19,000 odd items are already input in this. DRDO's Technology Development Fund, which is worth $13 million. Now, for that also, more than 5,000 firms have been engaged. Government focus on Atmanirbhar Bharat, Make in India and Startup India is really turning the tables now. Now, already we are exporting defense items worth 1 lakh crore to 79 countries, and the number is increasing day by day. We were not a defense exporter. In fact, we were the biggest defense importer, and now we are 17th in the world as far as exports is concerned. And to Africa, Myanmar, and few countries, we are the largest defense exporter. 1,400 transfer technology agreements have been signed between DRDO and domestic defense industry. And items have been banned for import in phases. So these items have been banned in phases, that is 3,738 items. Now, coming to other sector where things are happening at a very, very fast pace is semiconductor manufacturing. This Foxconn Vedanta joint venture for $22 billion, that is also likely to come up. The government has sought applications for phase 2 now, and they will shortlist the firms very shortly. And this is a 76,000 crore opportunity in India. Now, 1 lakh crore has been earmarked for domestic industry out of capital budget of defense forces. And now our R&D budget also, for the first time, our 25% of R&D budget has been kept for domestic players, and that amounts to 565 crores. And the beauty is in the IPRs. The number is increasing. It is 1391 as on date. And in space sector also, which is part of defense sector, the companies or the startups have already raised $245 million. Now, we are the country with the 3rd largest military expenditure in the world, and the MOD is the largest employer globally, employing 2.92 million people. We have 41 ordnance factories, which have been converted into 7 defense PSUs. So as on date, we have 17 PSUs. Tata Advanced Systems joint venture with Airbus. These people are coming up to manufacture this military aircraft C295, and Safran is coming up with $150 million aircraft MRO facility at Hyderabad, which is creating 600 jobs. General Electric, Rolls-Royce, they are coming for jet engine. And recently, last week only, HAL has announced that they are going to manufacture 470 LCA aircraft, that is Tejas, out of which 370 will be for Indian Air Force, 100 will be for Indian Navy, and for 20, they got the interest from other countries. 2 countries, they are sending 20 aircraft, and more countries, that is 14 more countries, are shown interest. This IDEX initiative, that is Innovation for Defense Excellence, is getting 116 crore, which is increase of 93% over last year. This is going to give support to the startups in the defense sector. Now, Defense India Startup Challenge. This is a new initiative which is getting 45 crore, again increase of 95% over last year. And DEF Connect is now focusing on addressing the problem statements. This is again a new initiative by the Government of India. Now, I'll also share a statement with you of ET Prime, which I read on 14th of Feb. It says non-IT sectors may dominate the white-collar market in 2023, maybe because of oversupply of IT professionals subsequently. Now, Kalyani Group joint venture with Paramount Group, it's doing good. They are producing M4 armored vehicles. They already have order for 90 of them. Bharat Force has got export order for 155 guns worth 155.5 million. And defense industrial corridor related centers of excellence are coming up. One at IIT Kanpur and IIT BHU Varanasi. IIT Roorkee is also setting up center of excellence for futuristic defense technologies. BrahMos aerospace plant, which is coming up between Lucknow and Jhansi, 300 crore is being spent on this. 15,000 jobs have been created in this, and we are going to export to 10 countries this particular equipment. Now, related to this, why there is a need for MTech defense technology, which was launched by DRDO and AICTE. Now, this has been launched by Amity University also. Now, it is basically because of demand-supply gap of the experts in this particular field. We need postgraduates who have the knowledge, skills, and aptitudes to carry out R&D activities in defense, and who have exposure of defense systems and the contemporary technologies, the latest technology. That's why we are having this international workshop in this important topic of study. We have collaborative efforts of 50 DRDO labs and industries which are giving exposure to students. Like our previous year students, they are doing internship and the projects at all the DRDO labs. We are creating jobs and the startup opportunity for the students so that they are able to participate in this mission of Atmanirbhar Bharat. At MIT University Gurugram, we are offering MTech in defense technology and integrated BTech MTech in defense technology, and the specializations of combat vehicle engineering, aerospace technology, communication systems and sensors, and high energy materials technology is being offered to the students who are keen on choosing this particular field of study. Now, with this, I finished. In case anyone has any doubts on any aspect, you can ask the questions from me.
Sir, one question has come up in the question answer.
Yeah, I can read that.
So this question is
Border system.
for the panelists. Can this border system also detect drones at low altitudes? Benjamin sir, would you like to
See, now again coming to the question, drones, what size? See, the major threat today in the battlefield is micro drones, which are the size of a small sparrow also. Now, these equipment have been developed to a very great, detail, and I cannot give the specifics, but definitely, if you ask me an answer for this, I would say yes. But in a condition that to a certain size of drone, it can easily detect.
All right, sir. Thank you, sir, for such a beautiful presentation. Thank you, Major General sir. You had also incorporated the various opportunities in the defense sector and why we require, what are the phenomenal opportunities in the defense sector, the government initiatives, and why we need to opt defense technology, what is the benefits of doing MTech defense technology, and how we have become one of the exports of drones, export of drones and the things like that. So thank you, sir, for such a good introduction. I once again invite to propose a vote of thanks. Major General.
Thank you, Dr. Sweta. Now, I have an important role to play here because the distinguished speakers, they have covered very, very interesting topic. And these topics, the way they covered them, it was really par excellence. In fact, I will be failing in my duty if I don't mention the key thrust areas which they have covered. Firstly, Professor Dr. Vikas Madhukar, Pro VC, he talked about optimum utilization of electronics technology for the welfare of people, especially the communication field. You see, importance of communications is understood by all of us. It can't be denied. And it is figuring in everything that we do, whether it's a mechanical equipment, in that also we have this. So besides this, the various programs that are being offered by MIT University, he gave a glimpse of that. So we are really thankful to our Pro Vice Chancellor. Then Dr. Mohammad Patwari, sir, he gave us in a very, very lucid manner the evolution from 1G to 5G and the developments that are taking place in the field of 6G. He talked about IoT, that is Internet of Things, cloud computing, edge computing, and also he told us about certain industrial applications of 5G. And now the ultra low latency and ultra reliability aspect and good bandwidth, these are very important features of 5G, which we are going to make use of shortly, and how it's going to benefit drones, robotics, and automated piloted vehicles. Also, a very good comparison of 5G and 6G was given to us, wherein this 10 microsecond latency is being aimed at 6G, and the present state of developments also were highlighted by him. Now, the best thing is the server size. The size of the server equivalent to the size of the credit card. So it's really fascinating. The edge processing as a service for consumer electronics, that was also discussed. And he also touched upon comparison of Industry 4.0 and Industry 5.0, the challenges in the field of cybersecurity, machine learning ability, and autonomous learning ability and reliability, which are paving the way for greener communication ecosystem, greener computing technologies, and greener data ecosystem. That is the future we are going to aim at. Then we had distinguished speaker, Mr. Benjamin Lionel, who has over 36 years of experience. Now, he talked about image intensifier based systems, night vision devices, which are developed by IRD Dehradun, uncooled thermal sights, which are developed by IRD, and MBT Arjun, that is Combat Vehicle Fire Control System, and this 3-axis stabilization depiction, which was done, any layman could understand that. The color coding of situational awareness system, which is giving us the prevailing threats in a very, very lucid manner. He talked about laser guided missile system, which is used for the tanks, and stealth aspect was also covered very nicely, wherein he talked about paper thin technology, bending of the light, which is making itself visible. So a technology which will prevent IR detection. Naval systems also, he touched upon the sensor system that is coming up to do the surveillance, and it goes down under the surface of the water. The airborne system, which is having a heads-up display, which is fitted below the aircraft, and it's giving information in the line of sight. Then infrared search and track system, which is a passive system, long range tracking it's doing of multiple targets. And also distributed aperture IR system, which is having a number of sensors mounted on the aircraft, which detect all the area around the aircraft. Then he talked about airports for the UAVs, which are generally belly mounted. And very nice video he gave us about all the systems, including Iron Beam of Israel, that is the laser missile defense system, which is getting deployed on land, in sea, and air, whose interceptions are really silent. And then robotic unmanned wildcat system of Boston Dynamics, which has a lot of sensors fitting it. So basically, the system of future, new autonomous weapon, anti-sniper, having camera sensors, which can penetrate and hit the target. That video was superb. So many people you can kill with very less effect on your own forces. So that way, the exposure that we got from the distinguished speakers was really phenomenal. I'm really indebted to both the speakers who are talking to us and benefiting our students from UK. Sir, I'm really thankful to you for sparing your time. And all of us, we profusely thank you for the time you have spared for this particular activity. Thank you, sir. Thank you so much, sir.
Well, thank you for inviting us. It is a good opportunity to see a lot of diverse range of people.
Thank you so much, sir. Thank you, Dr.
Thank you.
Muhammad Patwari. Thank you, sir, Benjamin, sir, for such
Thank
a
you.
nice presentation. Thank you, Muhammad, sir. Thank you, Major General J.S. Tull, and all the Pro Vice Chancellor, Professor Vikas Madhukar, and all the Amity University faculties, HOIs, along with all the students who have come up with us from India and abroad. So thank you so much. This has been the very great lecture with the great eminent speakers from the abroad. And with this, we have come up with the end of today's proceedings. Thank you all for joining us
Thank you.
today.
Thank you.
Thank you, sir. Thank you so much.
Thank you.
We're grateful
Thank
to
you.
you, sir.
Bye-bye. Okay.
Thank you,
Bye-bye.
sir. Good day, sir. We can leave now, sir.